across the x-axis, right? Now, the 2 that's next to it, that's going to go ahead and be our vertical, what? Is it a compression or is it a stretch? Stretch, there you go. This is a vertical stretch of 2, okay? Alrighty, very good, very good. Now, if it's a fraction, that's when it's a compression. Does that make sense? When it's a fraction, it's a compression. Lower than 1, less than 1, okay? Very good. And I love how you said less than 1, because technically fractions could be bigger than 1 as well, right? Like a fraction of 5 over 2, I mean, that's not less than 1, right? So that 5 over 2 would be a stretch, right? So there you go. Very good. I'm glad you defined that better. Alrighty, now, that right there is transformations. I highly recommend you go over your transformation notes. Look over left, right, up, down, okay? Look over what's a reflection. Look over all that good stuff, okay? Because there will be transformations on the exam, okay? There will be. I believe one of the questions is you've got to like look at a picture and tell us how it moved on the graph, okay? Stuff like that. All right, number 11. We got our work cut out for us, okay? We got to go ahead and talk about the intercepts. We do not care for the line of symmetry per se, okay? We only care for the intercepts and asymptotes. Now, I'm going to go over these pretty quickly because there's quite a few of them, so try to stick with me. All right, x-intercepts, y-intercepts for a logarithmic function. Well, it only goes through the, oh, not there. It's going to go right here. It's going to go through 1, 0, right? And it goes right here and does something like this, right? Now, the only thing to make a special note of is the asymptote that is along the y-axis. So the asymptote is going to be at y equals 0. A lot of people call this a vertical asymptote, right? And then, oh, x equals 0. Big oof for me. No one corrected me. X equals 0, right? That's what we have in the notes. Now, what is the the x-intercept? Good. It's going to be 1, 0. And so that's going to be the x-intercept, okay? And that's essentially it. As long as you know those things, you're doing just fine. All right, square root. That looks like this. Starts at the origin and jets off to the right. Now, looking at this right here, it doesn't have an asymptote, but it does have an x and it has a y-intercept. What's the x-intercept? 0, 0. What's the y-intercept? Very good. Okay. Exponential. This one right here is this guy. Okay, this was the one I tried to draw for the starter. And it's passing through the y. Okay, so it has a y-intercept. That y-intercept is at 1, 0. Remember how the exponential and logarithmic, they're opposites, they're inverses of each other? So that means the asymptote is not at x equals 0, but now it is at y equals 0. So the asymptote is at y equals 0. Now, the idea here, okay, is that a lot of people will reference these as the equations, but also as like the, I guess, attribute that it's at. They'll say that this thing is on the x-axis, so they'll call this the horizontal asymptote. So that might be worth writing down, that it's at the x-axis. Now, let's do the next one. Absolute value function, okay? Looks like a V. It does not have an asymptote, but rather it does have an x and y intercept, right? What's the x-intercept? Good. What's the y-intercept? There you go. Very good. The rational function. Okay, now this one has a lot going on. This has an asymptote along the y and along the x. So you have two of them. So it's got x equals 0 and it's got y equals 0. And it looks like this on the graph. Now, does this guy have any x or y intercepts? No, it doesn't have any because the asymptotes prevent it from crossing the x or y axis. There we go. Now let's do the next one. Cubic function, okay? This one, a lot of people says it has like an S shape, okay? Goes at the origin, contrary to how that dot may look. So this one has an x-intercept of what? Good, 0, 0. And then what's the y-intercept? Very good. Good. And another way to talk about the intercepts is that it's at the origin, right? Does that make sense? So be aware that that's another way we could describe it is at the origin. Now, the quadratic function has the shape of a u. Okay. Now, since it has the shape of a u and passes through the origin, it does have a y and x-intercept. What are they? Very good. That's exactly what they are. Okay? And you'll notice that is the case for a lot of the parent functions, right? A lot of them start at the origin, right? So keep in mind on that as well. Last one, the cube root function. It looks very similar to the cubic, but a lot more, I guess you could say, skinny or flat. Passes through the origin as well, which insinuates that we have an x-intercept and a y-intercept at 0, 0, and then 0, 0. So, ladies and gentlemen, that right there are the parent functions in a nutshell, okay? The only ones that have asymptotes are going to be your logarithmic, your exponential, and your rational. The others, they basically start at the origin or, pass through the origin, okay? So kind of draw some connections on some of these parent functions as a whole, okay? And also, please, please, please understand where the asymptotes are located for these particular parent functions, okay? Really understand exponential, really understand logarithmic, okay? And also take special note of rational, especially for your exam, okay? All righty. Any questions about these 8 parent functions? All right, easy peasy. Now, here's a good example of what I was mentioning on how, I want you to describe how this graph was affected and how it moved. So the idea here, ladies and gentlemen, is that the dashed line, the dotted line, this is where it started. The solid line is the movement, okay? And you'll see an arrow is pointing from G to H. So we're going from G to H. Now, looking at this right here, this thing went to the right and then it went down. Does everybody see that? So looking at that dot, how far to the right did it go? 4 is correct. Now, if we were articulating that as far as the transformation is concerned in like function notation, would that be an x plus 4 or an x minus 4? Caleb got it on this one. It'll be minus, okay? Okay? Plus means left, minus means right. Careful of that, okay? Now, the next one, how far down did we go? 2. Now, does that mean, as far as function notation, does that mean we write a plus 2 or a minus 2? All right, very good. This one is indeed a minus 2. Now, this leaves us with H as our answer, okay? Now, does everybody see how the transformations apply to this picture? Pretty straightforward, right? Not too complicated. All righty, very good. Now, here we go. Here is the next one, okay? So now we're looking at this new function notation, and we want to understand, what happened to f of x, okay? Because we have this new function called g of x that has the transformations in it. There's a negative on the very front, right? You'll notice it right here. Oh, moving my paper around. Right here is where my eyes are. That negative in the front, what is it talking about? Very good. It's a reflection. Now, if you look at this right here, it's a reflection across what? Because you've got y-axis, and then you've also got yourself the x-axis. So which one is it? The x-axis is correct. So automatically D and C do not work. Does that make sense? Alrighty, perfect. Sorry to let someone in. Alrighty, now the next one, there's a minus on the inside now. Is that indicating that we are going to the right, or is it indicating that we are going to the left? Very good. It indicates that we're going to the right, so my answer is going to be A. Now, do you see how I systematically answered that question? You'll notice there's a lot of words going on, okay? But all you have to key in on is the major ones. You see what I mean? Look at the simple verbiage, left, right. Look at the simple verbiage, x-axis, y-axis. You see what I mean? Because what happens is a lot of people get overwhelmed by the sentence because they're like, a translation to the right, C units. Don't do that to yourself. Highlight the key words, okay? And then simply apply it, okay? Now, let's go ahead and take a look at this next one, okay? All right. Yo, yes, sir. So it goes to the right if you have something like x minus a number, that means right. If you have plus, no problem, sir, that means left. Okay. No problem, Matthew McConaughey. Alrighty, now, looking at this next one. Plus 14. What does that tell us? Very good. We're going to the left. Now, the minus 12, what does that tell us? Good. So let's look at the simple verbiage. We have down, down, up, up. Well, clearly, C and D are not going to work, are they? Now, which ones will work out of A and B? What'd you say? B will? Okay, because left versus right, and left is where we're going, so B is correct. Alrighty, so there you go. So that's how you do it, okay? Just look at the simple verbiage. All right, let's keep going. Now, this next part right here, ladies and gentlemen, this is talking about domain and range. Now, we're going to have to understand it in terms of interval, okay, as well as set builder, okay? Now, this may be a little bit of a refresher, so let me help you with the first one in its entirety, and I think you'll kind of get the idea again. This graph right here, the one that's shaped like a parabola, the U, the quadratic, has some arrows that are indicating that it's going to the left and to the right forever. Now, when you start saying the word forever, that tells us that it's going to negative infinity and positive infinity. Now, that is the domain, so you say from negative infinity to positive infinity. And so here, you don't put brackets around infinity, okay? You put parentheses, okay? Because you can't include it. Remember, brackets mean include, parentheses mean to not include, to exclude, okay? Now, the range, remember, read from bottom to top, okay? So how low that was a terrible drawing. How low the graph goes to how high, okay? The furthest down this graph goes appears to be a -4, okay? Now, -4 is a tangible point because it's a solid line. Does everybody see that? And so this deserves a bracket, okay? Now, you'll notice the arrows, though, are going up, and we say forever towards positive infinity. Now, that, of course, is not something you can include, so you have to put a parenthesis, okay? Now, are there any questions in regards to that right there? Everybody doing all right? Bueno, bueno. Now, the domain for the next one, okay, for set builder, requires the very special notation. x is such that, okay, remember you're going to have to do your x is such that x is an element of the all real number system. Now, this special notation is only used when you have all real numbers. Does that make sense? When you go from negative infinity to positive infinity. Okay? Now, another way of saying it is all real numbers. Okay? And I really hope that you pay close attention to that special notation. Okay? Because I guarantee you it'll show up on your exam. Okay? Now, the range, though, we're going to be using an inequality to describe it. Also, be aware that when you're talking about range, you put a y. You see what I mean? It's not always x, okay? So here we have y, and y is, of course, greater than negative 4, but also equal to, right? Because we can include it. So we're going to say that y is greater than or equal to negative 4. And then there you go. That is the set builder notation that describes the domain and the range, okay? Any questions about part A of number 15? All right, easy peasy. Now, number 2, I'm going to ask you to help me out a little bit more. Remember domain, we read it from left to right. How far to the left does my graph currently go? Negative 3 is correct. Good job. Now, for the negative 3, it has an open circle. What is that? Is that a bracket or a parentheses? Good, it's a parentheses. And then now look towards the right. How far to the right does it go? Okay, 5 is correct, but I encourage you to say positive 5. No, it's okay. And I think it's because you saw it down here. And it makes you think negative. So no worries. Now, the range though, I'm going to piggyback on that idea of it being negative because the lowest value is negative. And I believe it hits right there. That looks about right. So I guess, how low does it go? Now, good. So for negative 4, is this a bracket, parenthesis? What am I working with here? Good. It's a bracket. Because you can include it because it's a closed circle, right? Now, a lot of people end up making this mistake because their eyes immediately go to it. Remember, the range is read from bottom to top, and the idea of top is the maximum height of the graph. You see that? Don't let your eyes be fooled by the circle, okay, over there on the left, okay? So what is the maximum height that this graph will reach? Good. Now, at 3 in particular, is it a bracket or a parentheses? Bracket is correct. Now, I'll tell you why. Remember, because it's a solid line, you include it. If it was dashed, you would say no. Does that make sense? Remember, dashed lines mean no, don't include. Solid lines mean to include. Good job, good job. Now, the set builder, let's talk about it, okay? Since we're doing domain, we're going to say that x is such that, and the x is wedged between the numbers negative 3 and 5, okay? That's where x is between. Now, the idea is that x can be less than or equal to positive 5, right? It can be all the way equal to 5 or less than 5. But x is going to be always bigger than the negative 3. Now, you don't put an equal there because it had a parentheses. Does that make sense? And then voila. Now, the range is also written very similarly. Your y is located between negative 4 and 3. Now, your y value, it has to be less than, but could be equal to the value of 3. And your y is going to be bigger than negative 4, but could be equal to negative 4. So it deserves both a less than and an equal to. Okay? Everybody good there? Okay. Awesome, awesome. Okay? Now, let's look at graph number 3. Graph number 3 says, as far as domain is concerned, that we're starting right there. And we're going this way, right? So how far to the left does my graph go? 4? Negative 4? Okay. Now at negative 4, do I get a bracket or parentheses? Bracket. Now how far to the right is my graph going? Great job. Positive infinity is correct. Now let's discuss the range. The range hits right there at negative 3. Yep. And looking at this right here, I know that it can be deceiving. A lot of students will sometimes let their eyes be drawn to this right here. They're like, oh, that's the height. No. What is this arrow doing? This arrow is going up, right? It's going up and up past that point, right? And so because that arrow is going to go past that closed circle, it's going to infinity. So we're going to say that it goes from negative 3 to positive infinity, okay? Now let's discuss the set builder. We're going to say that x has to be greater than or equal to negative 4, right? Because it's a closed-in circle and it got a bracket, okay? Now the range is going to be y is greater than or equal to a negative 3. And then there you go. There is our set builder and interval notation for number 15. Now, ladies and gentlemen, are there any questions about A, B, and C for number 15? All righty. Easy peasy. Caleb, good? Miss Autumn, how you doing? Good. Okay. Now, let's go ahead and take a look at number 16, okay? This is Unit 3. Now, Unit 3 was all about the absolute value, okay? We're going to go ahead and have to go through the process of solving for x, or p in this case, all right, when you have an absolute value. Now, the first thing you have to do is isolate the absolute value, right? You got to get it by itself, nothing around it. So what should we do first with that plus 2? Good. Very good. And let me zoom in so that way I have more space. Subtract it to the other side. So then I have 3p plus 2 is equal to 7. Okay? Now what do we do? No, you're good. We have 3p plus 2 equals 7. And 3p plus 2 equals... There you go. There you go. Remember, you got to look at it from both sides, both the positive and the negative. Okay? Now, let's go ahead and subtract that 2. So subtracting the 2 on either side, what's 7 minus 2? Divide by 3 on either side. P is going to equal 5/3. Okay? And that's okay. Fractions are good for us. Now, we're going to subtract by 2 on either side. And I have a 3p is equal to a negative 9. You divide by 3 on both sides. And p is going to equal negative 3. And those are your two answers. Now, how would you check if they were extraneous or not? Where would you plug them back into? Very good. The idea is that you would plug this right here. You see that? And then you would plug this one also right here. Okay? So, if you needed to check, that's where you would plug it in. Okay? I'm under the impression that these will work out just fine. Okay? But always make sure you check your answers by plugging it into the original equation. Okay? Let's take a look at this one. Okay? Now, the first thing we must do, as always, is get the absolute value by itself. So what do I have to do with the minus 3? So I have x minus 24 is equal to 2. Now what do we do? Yeah, we're going to do it on either side, right? So we have x minus 24 equals 2. X minus 24 equals negative 2. So now we're going to go ahead and do what with the minus 24? Very good. And of course, you'll do that on either side. So x is going to equal 26, right? And then over here, x is going to equal 22, right? And voila, there you go. Any issues or questions there? Alrighty, we're rocking and rolling. This one, this is a special scenario. Can the absolute value equal a negative number? No, so this is a no solution. Very good. Because absolute values are always positive, okay? Now you might be wondering, well, why didn't we say that this one was a no solution? Well, that's because we had to go ahead and get it by itself, the absolute value, and then looking here, this is not equal to a negative number, okay? Which is why we were able to proceed. Does that make sense? Here, there is nothing for us to do, right? It's already absolute value is equal to the negative number, okay? So that is why there is a no solution for part C, okay? All righty, here we go. Now let's do number 17. This right here is now the absolute value, but with inequalities, okay? The only thing to remember is when you're working with an inequality, what do you have to do with the sign when you make it negative? Flip it, good. So here, absolute value is already by itself, so you have yourself the x is going to be greater than or equal to 1, and then x is less than or equal to negative 1, okay? Because I had to flip it. Now, when you go to do the number line for this guy, you have it at negative 1 and positive 1. What kind of circles do we have at these individual numbers? Great job. Great job. Now, which direction do we shade for the, yes, well done, the outside? All right, over here. Now, what about the negative 1? Very good, very good. Now, if you're wondering how your fellow student was able to see that so quickly, it's because if you look at the arrows, right? This here, this arrow is pointing to the left, or I mean not left, to the right. And then this arrow is pointing to the left, okay? So the idea is look at those inequalities as arrows, and they tell you which direction you should be shading. Well done. Now, let's do part B. Here, we do not have the absolute value isolated, so we need to go ahead and divide by 2. So this is z plus 5 is going to be less than or equal to 25, okay? Now, looking at this right here, we are going to go ahead and split it down the middle. I have myself a z plus 5 is less than or equal to 25, and then z plus 5 is greater than or equal to negative 25. Now, ladies and gentlemen, what do you do with the plus 5 here? Great job. Subtract it. And so by subtracting it on both sides, you have z is less than or equal to 20. And then over here, subtracting 5, once again, you have a negative 30. So be careful, okay? Be aware. Now, of course, when you go to do your number line, looks like this. You have yourself a negative 30. You have yourself a 20. Now, at 20 and negative 30, once again, we have closed circles. Closed circles. And we're now going to determine which way we shade. Now, go ahead. The inside. Man, she's good. Okay. Yes, it's to the inside, because if you look at the 20 as an arrow, it's pointing inside of it, right? It's pointing this way. And if you look at the 30, it's pointing inside also to the right. And so, boom. Well done. Okay? Now, something to make a special note of. when we were doing this once upon a time and you were doing the assignment, this was an example of saying z is going to be greater than or equal to negative 30 and z is less than or equal to 20. So this was an and statement. Does everybody remember that? It was an and statement. Now over here though, this is an example of an or statement. You would say that x is going to be less than or equal to negative 1, or x is going to be greater than or equal to positive 1. The no man's land right here is the or. Okay? The no man's land. Okay? Perfect. Okay? So there we go. Now let's take a look at this. Haha! Another special solution. If you are less than a negative number, is that possible for an absolute value? No, it's not possible. This is no solution. Because absolute values are always greater than negative numbers. If I had this, how many solutions would I have here? Oh, here. Actually, I need to take this off. How many solutions would this be? Infinite. Does that make sense? Because absolute values are always greater than negative numbers. So that's why you would have infinitely many solutions. Okay? There you go. Alrighty, this next one, finally, on to number 18, and then we're good. So for number 18, ladies and gentlemen, this is the tolerance equation. Remember, the equation for tolerance is x minus your goal is equal to your tolerance. Another way of thinking about it is x minus the small number, or back that up, minus the big number is equal to the small number. Okay? So in this scenario right here, the recommended weight of the soccer ball is 430 grams. The actual weight allowed to vary is up to 20 grams. Okay? So when looking at this right here, for lack of space, I will write it right here. I have myself a x minus 430 because that is what is permitted. That's our goal. Is going to be equal to the 20. Now that's what it's allowed to vary up to. That's the tolerance, what we're willing to tolerate. Now if I want to find the maximum and minimum, all I have to do is simply split it down the middle and do x minus 430 is equal to 20, and x minus 430 is equal to negative 20. Does that make sense? Now all you have to do is add on either side, and x is going to equal 450. And over here, x is going to equal 410. Now, of course, ladies and gentlemen, which is the maximum here? That's right, 450. Good job. And then what's the minimum? There you go. All righty, ladies and gentlemen, voila. There you go. That's it. So number 19, that right there is just another transformation one. Shouldn't be too bad. And then I guess when we come back tomorrow, we will finish up and start on number 20, and we'll be ready to rock and roll on this exam, okay? Great job today. Now, guys, I'm going to go ahead and take attendance, so please stay on the Zoom. Please stay on the Zoom. Thank you.